All right, Algebra 1, we are working on lesson 6-7, and we are working with long division for polynomials. This is one of my favorite lessons. It's super fun. Our essential question is, can you divide polynomials? All right, so we're going to take a look at this one right here that we are dividing. We're going to do this a little differently, just like you did long division. We are going to take 4x minus 3. I'm just looking for a place to do it. I don't like my setup right now. There we go. 4x minus 3, and we are dividing it into, I'm going to put this in order of x squared, x, and constant. So 12x squared plus 19x minus 21. Now we've learned that you could factor these, and the factoring works great, but sometimes the factoring doesn't work. So just like long division in good old elementary school, we're just going to look at first into first. And this is the kind of confusing thing, because every time we're looking first into first. So how many times does 4x go into 12x squared? 3x. Now we have to take this 3x and distribute it to each term. 3x times 4x is 12x squared. 3x times negative 3 is negative 9x. Now, one thing that you have to get used to with long division is, remember when you're doing elementary math and you're just doing long division with numbers, you subtract. But remember, this negative has to distribute through to each side. Now, our goal is to make that first term cancel out. Well, 9 plus 19 is 28x. And we're going to drop this negative 21 down. So now we're going to look first into first. How many times does 4x go into 28x? Good. 7 times. So 7 times 4x, again we're distributing, 7 times 4x is 28x. 7 times negative 3 is negative 21. Don't forget to change all the signs. And notice this one has no remainder. So my answer here is 3x plus 7. So that is polynomial long division. We're going to do a couple more. Sometimes they don't work out. But I think I'm going to go down to this one, example 3, because this one is really crazy because it's going to continue on, and I have a gut feeling it's going to have a remainder. So notice we have y minus 1, and we're dividing it into y cubed plus 4. But we don't have anything for y squared, so I need to mark that. I don't have anything for y, so I need to mark that. And the 4 is the constant that stands alone. So let's go again. This one looks like it's going to be a little longer. Y goes into y cubed, y squared times. Remember to distribute. Y squared times y is y cubed. Y squared times negative 1 is negative 1y squared. What do I do with the signs? I change them. So we have to change all the signs because that negative has to distribute through. 0 plus 1 is 1y squared. And we're going to drop this 0y. So notice we had to put in these zeros to mark our space. How many times does y, first into first, go into 1y squared? Y times. Again, we're going to distribute. Y times y is y squared. Y times negative 1 is negative 1y. You could show the 1 if you want. Change the signs. And these cancel out very nicely. Add down. 0y plus 1y is 1y plus 4. And it looks like this one's going to have a remainder. How many times does first go into first? Well, y goes into y 1 time. 1 times y is y. 1 times negative 1 is negative 1. What do I have to do with those signs? Good, I have to change them. Change those signs. And when I add down, I do have a remainder. So you're going to say, hey, what do I do with this remainder? So my answer is y squared plus y plus 1. But since I have a positive remainder of 5, I have to show my remainder up here as a fraction, 5 over, and we're going to put it over this denominator, y minus 1. So let me write that a little prettier for you so you would know how to write that out. Our answer is y squared plus y plus 1 plus 5 over y minus 1. And that would be the answer.